So hello everyone, my name is Andy, and I am a student helper at the University of Washington. And today I will make a homework walkthrough videos for Meta 24 from this quarter to every quarter until 2024. I will make a homework walkthrough video for every section of the web design homework. My intent to do so it is to reduce the time on you to struggle on the homework. Rather, I will give you some hint about how to approach this problem, and you can just save a lot of time on doing it. And I know you're a college student, you have lots of things to do. Maybe you're a freshman, sophomore, who are applying many for many tough major, and I know you want to have more time to study for other class. So I want to save your precious time, just to make life easier. So in this video, I'll be talking about section 2.2, which is the graphical approach of the limit of a function. So for this question, we just read just read like this chart. If the limit at for one value they're not equal, then the limit does not exist. For this here, here is like from the left side, x approaches to the left side, 8 equal to 3. Right side is a 1, and we cannot just a 1 plus 3 over 2. 2, it is not a limit at x equal to 2. The limit exists if the both side limit they are equal and exist. So read the graph, make sure to put all function value here, just read the graph for first one. Same for the second one. Actually, for the function at x equal to 2, it is defined, but x equal to 2, the limit it still not exist. Same equal to x equal to 0 when the left side limit is not equal to the right side limit. It's the same thing. Pay attention to the right and the left side limit. Just to read all the graphs here, pay attention to the signs here. If you see generally see like a less than, this is excluding this point. So it is like empty dot for only smaller sign. But if you see like less or equal to the sign or larger than equal to, it is a colored dot. It's a solid dot. So the rule of thumb for matching a piecewise function, it is solid empty dot for no equal to sign or only for smaller or larger than, and a solid dot for smaller or equal to or larger than or equal to. This is for smaller, and this is for solid dot. You have to make sure where the discontinuity is. If you plug a -1 is a 1 and the 2, this is the discontinuity at x equal to -1. So just plug those numbers, put their upper and lower end of each interval, you see the behavior of the function. For here is a 0, limit here. So we do not have a limit evaluating strategy for section 2.2. We just approximate from here to 1 here. We can do from a 0.9, 0.99, 0.999, or 1.1, 1.01, 1.001, the determinant behavior. From the right side, so putting the number from is larger than -7. So we go from -6.5, then go from -6.9, then goes from -6.99. Then the say like its own, even though it is a positive for all like fractions. So the limit is going to infinity here. As we divide a number with an arbitrarily smaller number, the limit is equals to positive infinity or negative infinity. Same thing for number 6, number 7, those two. It's the same thing. And this one, use the right and left side limit. Just use a table to approximate. When x approaches -7, when x approaches 3 from the left and the right side, you see that where the function's output is. Then you will see the trend from like the y value. That is what you can expect for the limit of the function. So for infinite limit here, you will learn it in section 2.6, which is like the horizontal asymptotes. But here, just this same thing. Just to read like graph here. You see here is like the jump discontinuity is, and where the limit is. And for here, you just use them to approximate, because like you have not learned the limit evaluation strategies yet. So I'll be talking about later in this after this videos. I will talk about this one. I think I will make a special like study guide for this problem, but this may not be a like question on the final, but be careful for the midterm. But I would make a special attention on this one. And number 14 will deserve like a special attention. Thank you so much, and I hope you find my videos helpful. So when you make it, please hit subscribe so I have more update on my math video and everything. Thank you so much. Have a great day.